All right, so I want to introduce this next version of what's going on inside of our code. Specifically, we have the height map being added to this, a form of something that you see inside of the hills inside of I was going to say Unity, Minecraft biomes. So this is starting to look a lot more like Minecraft now, where we're seeing those biomes and structures begin to appear. Now, this is not approaching it the same way that they would. In fact, we probably will switch over to something a little bit more along those lines. But to be honest, I've been wanting to play with this pattern of letting something just kind of go out and do what it's going to do, and then we'll see what we want to change. All right. So anyway, with this, there's some information in this bot that is different from some of the previous versions. So first off, we have Perlin noise being used in this, and I'm using Unity's built-in Perlin noise function, where you basically just pass in an XY vector, vector 2, and you get the results pack out of it. Now we also have amplitude, so basically any of these, the maximum height that can possibly be reached is 10. There's rise time in this, so you can see that it's animated in how it rises, and that is half a second. In 0.5 seconds, it will go from its starting position, or just below the water, to whatever its resting position is. Now, as a side effect, as it's rewriting areas, since the position is not being simply stamped into place, then because of the fact that when it rewrites those positions, the Perlin noise remains stably the same, we actually get to witness it rise. We get to see the changes for where it's happening, because it actually rewrites terrain right now. It'll, as it goes through its point of focus, it will find whatever pieces of terrain are around it and just keep rewriting it. Generally, that means it'll end up the same every time, but there are some distinctions in how the forest is generated versus how the rise system works that gets offset in time, and we don't see the forest get uniformly risen to the sizes here. Sometimes it happens. So you can see some of the forest is risen up, but then you see these sheer cliffs dropping down in the forest down below. So a lot of times the forest ends up in these cutouts, but I like the appearance, so we'll keep it. Anyway, a little bit more. The stone bot, I had to put in camera tracking. Actually, did I put in camera tracking last time? I think so. Yeah, I did. Okay, so camera tracking was put in last time. Anyway, so then I've got the prefab for the stone cube. The stone cube prefab is pretty straightforward, so let's just go find it. Project, and then stone cube, and let's click into it. There's nothing special about it. It just has a cube script, and it has the type set to 3. There's no important reference, at least not set here, and everything else is the same. Aside from that, I added a gray material to use for the stone, which just basically has a low metallic map and smoothness, so we end up getting this effect on it, or the white that you see here. Okay, now that is some of the key distinctions in what we're seeing inside of here. There is another thing which we don't really see. Let's see if we have this inside of the prefab. If I expand out the prefab, you'll see that, oh, well, that's a waste on performance. I duplicated the forest prefab for this one, and I forgot to remove all these extra items. That should move a little bit faster just because it doesn't have all this extra stuff to load. By the way, performance is something that I will be addressing in this, but I have not done yet. So let's just go back and now save twice and play. The loading performance should be a little bit better here. But then we should start diving into code. Yeah, I can't really distinguish the loading performance, but the recording time for me to do a 1 hour recording of this animation at 60 FPS and 1080p ended up taking, I think, maybe like 3 or 4 hours. I don't know exactly when it ended versus when I started. I should probably have tracked that. Anyway, let's start diving into how this code works. So the big thing is the stone bot, which also should have been called riser bot. I called it stone because I was putting stone blocks into place underneath this initially. And I was considering the idea of stone surfaces on the top as well, like cliff faces, and that this might be separate. So it started in one direction and I changed it as I was going because I like this route better. Okay, so stone butt. Here's the basics. We got the variables that we just saw and I just went over. Let's see if there's anything beyond the update. There is setup rise. Okay, so let's do setup rise. Basically, at this point, we've understood that there is a height that we want to take one of the cubes that we've just seen, and we want to push it to that height. Of course, that has the rise, it has the adding the stone underneath, but otherwise keeping the initial prefab that was on top, whether or not that was the forest that might have a tree sitting on there, or just the grass that's just the single cube by itself. Okay, so anyway, the rise is basically just saying, hey, take this cube and set it up with this height. How high above sea level is it? So in this one, we're going to store a couple pieces of information. So we've got this riser component, this riser script. Actually, I should go into that then. So riser, very simple. It has target and an origin. So what height are we going to? What position are we going to? Because technically this doesn't need to be up. We've got the origin position, the target position. Then we have how much time is it going to take and how much time have we taken. All right, so inside of this, we're just going to increase the time counter by the delta time. And then we're going to take the time counter. And if it's greater than the total time, we'll set it to there. So we don't end up with an outside of 1 or 0 value. I could have used clamp 01 like I had in the previous videos, but this is the first one I came up with at the time. All right, transform position. We're setting the position to lerp from the origin to the target based on this value. So that should be a number between 0 and 1 at this point. And by the time that we have set that value, we're also going to evaluate that if the time counter equals the total time, then we're going to destroy this. Now remember, this is not the game object. This is the riser component. It might have made more sense to simply disable this versus that. So when you're thinking about performance and things like ECS, this taking away the riser component would effectively have required moving this into a different struct or into a different chunk of memory. But that's not really the concern of what we're discussing here. Anyway, let's take the rise. We've got the riser taken off, and this is all that it does. It just takes an object and pushes it up, just one object. Okay, now the stone butt. So we've taken that riser, we're set its origin and its position. Its position is basically vector 3 int up times count. That's the target that it's supposed to be. So our new cube is supposed to be up there on the top. Now what we're going to start doing is we're going to instantiate the stone cubes underneath it. A more performant way to do this would have been to simply instantiate one cube underneath it and expand that out, or stretch it to fit the size that's required, or just make it 100 deep to begin with, or whatever the maximum size was, Perlin amplitude, that one. Okay, anyway. But whatever the case was, we're creating a single cube for every single one of these. So for int I to count, and the count is based on the amplitude, we are going to instantiate the prefab, which is currently the stone or the cube. We're going to set its position, which is whatever our current cube's position plus vector 3 down times whatever the I position is. So first one will be 1 down, the second one will be 2 down, etc. Rotation is stagnant, or the original, and the parent object will be the cube transform. So when the cube rises, these other objects will move with it. Okay, so that's the rise function. Now, how do we actually determine what height those are supposed to go to? Let's go into our update function. Okay, so first thing, we're getting our target, which right now is currently based off of the camera tracking target. So that camera tracking is, that's what we switched our ground bot to be able to work with as well. And our forest bot, they are paying attention to camera tracking. And now we are going to get the cube at the target that it is currently looking at. Okay, so we've gotten the cube, and now if the cube is null, so we looked at the position that the camera is looking at and it doesn't have anything selected, then we're just not going to do anything at this point at all. We're also going to check to see if the ID is not 1 or 2. So if ID does not equal 1 and does not equal 2, then we'll return. So we're only going to operate with 2 known variables at this time. That's one of the key things to consider when you're doing a procedural generation, especially where you're going to be adding new elements along the way. Lock the elements down. Don't make them generic where they always do a thing. Lock their conditioning down to the other elements that you know about, specifically ID, the types, for instance. That it will only do this when it is these types of cubes, versus the idea that just don't do this when there's a null cube or when there's a water cube. Because as you add new elements, those new elements will not be known to this, so its rules should not be affecting it. Anyway, so this is only going to affect certain cube types and states that it understands now, and that should remain relatively safe as we expand this. Then we can decide, oh, well, we added waterfalls and rivers, and this doesn't have those waterfalls or rivers. So we need to make this also account for ID 76, which is our water with flow or something. Okay. Anyway, so we get the cube requirements. We make sure that we can actually use this cube. It's either a ground or a forest, and it is not null, so we can't place this in empty space. Then we're going to say determine the Perlin value. So the Perlin value, this is a simple function. I want to, hopefully in editing, I'll get this in here of showing up what a Perlin image looks like. But anyway, so it's just basically a black and white image where we have these ups and downs, and they have a smooth gradation from one area to the next, and it looks pretty random in the nature of how it's developed. Okay, anyway, this is a mathematic function, so basically it can just provide one number, and it will develop that number into a basic 0 to 1 value that every time that you ask for that number, you basically get this other number back. So it's like random. It feels random when you're distinctly going through every single one of these separate pieces or positions and putting them in. It can be hard to identify a pattern of like, this one is up, this one is low, this one is up, this one is low, because it doesn't follow a natural grid or line like we normally see, but it's this kind of wavering pattern. So Perlin noise is a really nice way to make things look a little more natural without any real effort. Okay, then I'm putting it through a curve. Now, right now, this curve doesn't really do anything, but it can be manipulated. The curve is basically saying that if I pass in a 0, I'll get a 0 back. If I pass in a 1, I'll get a 1 back. If I pass in 0.5, I get a 0.5 back. But I can alter that. So I could set up the animation curve inside of Unity so that this value, let's just go to this. And now look at what it's doing. I just changed the structure of it. This one is a really, really strong impact. But on this one, we're seeing that every position that it goes to, it's basically going to set it at either 10 or 1. Or actually, yeah, 10 or 1. And there's nothing in between. So if I now took this and I positioned the height down, we're going to see more changes in height here. But let's see, I'll take this one and add key. There. No, I want to break that. Oh, I can just do that. That works. So now we're basically never going to see anything at 0. So when I go into here and let's scroll up. Where is that? Oh, camera's way over. There we go. That's actually kind of surprisingly hard to validate in this, but we're never ending up getting something at a 0 height anymore because that almost doesn't exist inside of this equation. In fact, I could just take the bottom variable and just move that up to here, and yeah, we'll never get a 0. There. But it has to do this. It's not going over all the stuff it already did. Anyway, but that's what this does. It lets us tune those numbers so we can come up with other ones that we like. What? There. And then there. Okay, so this is back to what it was. It was basically a 0 to 1 scale that matches 0 to 1, because that one just works well enough. Okay, then we're going to multiply that by amplitude because our value was between 0 and 1. So now we're going to get a value that is somewhere up to 10, up to 5, up to whatever we have that Perlin amplitude set to. And now we're going to do a special validation that if the amplitude is less than 1, then there's nothing to rise. In fact, we might argue the other way too on this one. This might have been better for 2. I haven't thought about that, but whatever. Okay, anyway, so then assuming that we have not exited at this point, that we have a new height that should be 1 or greater, we will set up our rise for it. Okay, so anyway, we are rising. Oh yeah, 0. 0 was water level. So if it's 1, that means it's floating above water level, and we have half of the cube below it just cut out, so our grass would have looked like it was floating. Anyway, so we put a cube, 1 cube beneath that. So that's what we call our setup rise, which adds the extra stone underneath it and causes it to start its movement from the bottom to up. All right, those are the key changes. There was one additional change that I had to make, I believe, to the forest bot. Yeah, that was it. The forest bot. Can this actually show me where those changes were? Oh, here. Okay, so the cube system, it doesn't show me the original in here, but, oh, wait a second, can it? I haven't asked. Yay, okay. So originally I wasn't doing anything up here, but in this time we're getting the actual cube that it's interacting with in the forest. So the forest wants to get whatever position that was. We actually had an error where we were getting duplicate objects that were showing up, and until I had the rise up showing up, never saw it because side by side they were covering each other up with other faces on the surface. But as soon as I had that rise where it started moving up, gradually, then I could see that I suddenly had faces that were overlapping, and they would you would see that flicker as it chooses which one of these it's going to actually render ahead of the other, based on just the fact that floats are not completely accurate. Anyway, but so in this one, I made sure that I'm putting something in there to destroy the original cube. We take the original cube and destroy it. Now, this is not performant. I should be operating a pool. I should have something where all the items that were in the past maybe just have their state recorded, but then their actual objects that were used to create them, the grass or the forest and the stone, that goes back into a pool to be able to be repurposed after the fact. Okay, and that would have helped out a lot. For performance, but I don't have anything in there for it, and we keep instantiating and destroying all over the place. Okay, but that's typically only 1 to 2 per frame that it does. So it's not a huge hit inside of this. The huge hit actually has more to do with just the sheer number of objects that we start working with and having to do any of these functions against. All right, anyway, so we have the cube system. We're just checking to see if we need to remove it. Then after that, can I expand that out? Okay, so then we were getting the cube, which we're still doing, but now we already have the variable name. And then we're checking to see if it has position, and we're going to remove it from that position if we already have the position. I got rid of that because in this case, we're removing it up here at the top if it already has the position. There was a specific reason that I can't honestly recall right now why I had that, and so maybe that ended up not being as important now that I'm looking back on it. But whatever the case, I ended up taking out a has position. So if we have a position, we're putting it in there, then we are going to remove it if there was one already there. Oh, yeah. So on this one, we determined that this one where it is placing a forest block, it's already doing a cube check. It has a cube. So that cube is testing to see, do we already have a cube here? And at this particular line, We're going through all the items in radius to check to see if we have cubes. If we didn't have a cube inside of this in radius, let's see. I had a specific reason. I'm having trouble remembering what it was. Oh well. Yeah, do we have something that exits? Nope. We don't have something that exits this. Return null is building false. Oh yeah, build forest. So build forest, the only reason we could build a forest is because there already were blocks surrounding us. Now at this point we grab the existing cube. Now we set the cube to get the forest's current cube. Because in this one, let's see, we're working with a forest. We instantiate the prefab. We're just building out a new prefab for it every single time. But if there happened to have been something there, oh, that's it, yeah. We're getting rid of it. If there happened to have been something there, we are destroying it to begin with. And now we're instantiating the new one that's going to have its new position information, because before it could have been instantiated without any position information. Okay, yeah, that was the key changes there. All right, anything else that I'm missing? Stone bot. Yeah, we went through the stone bot, which probably should have been riser bot. The riser code we went through. Camera tracking. Camera tracking had a minor change to it. I think there was a field that we weren't using. Let's go into camera tracking. Camera tracking, and that one shows up here. Yeah, it was just a deleted field, something we weren't using, which, can I see it? We had an animation curve here. That was going to be the rotation strength curve, which I ended up not using, or at least not at that position. Oh, no, we added it. I just simply moved it since it was public here, and the items work together here in this case, in my opinion. All right. So that was just a move, not a removal. And that should be it. Oh, move cube. There's a move cube function. That was new. So that's in the cube system. So cube system should also show up here. Move cube. So with move cube, we remove it from its original position and put it in its new position. This again has no validation that A, the position already existed, or B, that it's not going to overwrite an existing position. And that's because the validations are happening before this. Well, one thing when you're considering like procedural work, the algorithm that's actually doing the determination of whether or not it can place the block there often already is in possession of that piece of information. It can validate at that point without any extra expense, without any additional lookups, because it already has all those pieces of information looked up. It can look those up and pull them in and decide already whether or not we're going to be overwriting data or other existing keys. So that's an important thing to keep in mind. Now, of course, when we're talking about that level of this, it's better to also consider this in chunks, where we have like arrays or chunks of this information held together. So we would be manipulating a chunk of space versus an entire, just every individual cube separately. But we'll get into that. That's going to be some of our performance gains. Anyway, I hope you found this valuable. Performance definitely is taking a major impact on this. In fact, I bet we can see some of that if I were to throw not visualization in, but stats. So stats on here, what am I seeing? Frame rate. Yeah, 22 FPS. That's pretty bad. Let's go ahead and throw this at the beginning. So if I just start that, I didn't catch how many triangles or how many objects it had added by that point. But let's see what it starts out as. 120. It's well over 100 FPS to begin with. And then that number starts dropping down, and it's dropping down pretty quickly. We hit stages with this where the amount of memory that it's taking and what it has to load in starts to go through these immense changes. So to begin with, all of these variables could fit inside of one piece of cache RAM. So we ended up with much faster sets of execution, or one page of cache RAM. But then once we actually started going beyond that and we're having to do lookup calls between them, between like two of them, we suddenly see a huge expanse in the time where it suddenly would drop down from like 120 to around 60 FPS. And then we started to do more lookups where the memory started increasing, and we had to expand that out further. And eventually by the end of it, I don't know what it was running at, but I think I was getting like maybe 5 to 10 FPS total when I was looking at it, where it was about 50% of the way through in the processing, which was based on time, not the actual number of cubes that it is placed. Okay. Anyway, I hope this has been helpful. Please feel free to suggest things. I don't know how much longer I'm going to continue this exact path of generation because I'm hitting the performance issues. I'm looking at this as well as to how I'm going to change it. Like, what am I seeing? What do I want to keep? Because I didn't really have a direction with this when I started. So that's another thing to consider when you're looking at doing procedural generation, is the expense of it. There's always an expense. So there are systems that are out there that can do like Houdini, that can do these really incredible environments. But for me, I really like having all the control. And when you're talking about fully learning a new tool for this, the fact that you can already do so much with Houdini is amazing. So you don't, it's worth the expense. But sometimes there are layers of additional logic added, additional structure, or you need this operating at runtime, which I don't believe Houdini does, that you want in your system. So there's always reasons why you would want procedural generation by hand available to you now. Anyway, hope this has been useful to you. I'll talk to you later.